our project on portfolio optimization. First of all, let's start with our portfolio information. These are stocks that we considered. The stock we chose are mostly well known and we chose from many different sectors. In this case, we define decision variable as fractions of portfolio invested in stock I, or PI. The objective function is to minimize risk, is to minimize variability. And our constraints are 1. Average return has to be greater than or equal to 2%. 2. Sum of PI equal to 100%. And 3. The value of PI must be between 0 and 100%.
Let's move to the Excel for the solution. Here is the Excel on to find the solution to our problem. The top table here is the annual return table of the stocks that we chose, and below the table is the average return for each stock for the past year, which we can find the average here by using the average formula, and also the variance, and here's the variance formula right here. After we completed that, we then construct the covariance matrix. The covariance matrix is just a matrix between two stocks that we chose. And to find the covariance, let's take KBank and KBank as an example. Excuse me for that. KBank and KBank. To find the covariance of KBank, here's the formula, and the first array will be the data of the stock of the left column, which is KBank right here. And the second array, we gonna look at the top row of the table, which is the stocks here, and it's KBank. So we copy the same value as the second array, and then we fix the first array. We fix the first array because we will take the left column as the base, and it's the covariance between the left column and the top row. So the top row will be our second array, and the left column here will be our first array. After we constructed the table and we use the formula to find all the values in this table, we then construct the fraction portfolio table right here. The gray color on this table means that this will be our decision variables, which will let the solver solve for us of what should we invest in. And then we gonna go to the constraints, which the expected return should be greater than or equal to the required return. And then our objective function, which is to find the portfolio variance right here. The formula will be given right now. After we put in the formula for the portfolio variance, our Excel is now ready to use the solver function. To go to the solver function, we first click data, then go to solver. Then this will pop up. Let me do this to show you that we can get the answer. I'm gonna hit reset. We're gonna set the objective function as the portfolio variance, which we are trying to minimize the objective function by changing the fraction of portfolio, subject to the constraints that the expected return should be greater than or equal to the sum of the fraction portfolio should equal to 1. And now our solver is now set. We just hit solve, then we get the answer of 4.595 as our variance.
Thank you for your attention. We hope our presentation can benefit you in choosing and making your portfolio better and has less variance.